Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, I'm Mr. Wheeler and welcome to another edition of Lost in Math. Today we're talking about graphing linear equations on the coordinate plane. The graph of an equation is made up of all solutions to the equation. All of the points plotted are answers for whatever equation we're looking at. Today we're going to be talking about linear equations. Linear equations, if I plotted their solutions, they'd form a line. So if we look at our first example on our notes, it asks us to graph the linear equation y equals 2x plus 1. There are infinitely many solutions to this problem. It has an input and an output, an x and a y. So depending on what x I plug in, I'll get out a different y, and I can plug anything I want in for x. If I try to write all of them out, I'd never finish. If I try to write as many as I could out and then told my children to spend their lives writing out the answer and then told them to tell their children to spend their lives writing their answer and so on and so forth, your great-grandchild would be no closer to writing them all out than you are because there's infinitely many solutions to this problem. So to avoid the spurn of your great-grandchildren, we can show our solutions on a graph. A graph shows all solutions to a linear equation. It has arrows at the end of it that go on forever in both directions. So pictorially, we can show these are all the solutions and they'll be along this line if it's a linear equation, which is all we're going to be dealing with today. So on our example, y equals 2x plus 1, we can plug anything we want for x. For our first example, I gave you some x values to start with. So we'll just be plotting 4 points to save our sanity. The first point is negative 1 for x. So that's my input. So I plug negative 1 in for x. And instead of y equals 2x plus 1, I get y equals 2 times negative 1 plus 1. 2 times negative 1 is negative 2. And negative 2 plus 1 is negative 1. So when I plug in a negative 1, I get out a negative 1. So my first ordered pair would be at negative 1, x comma y. My next x value is at 0. So I input a 0 into my equation. I get y equals 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. So when I plug in a 0, I get out a 1 at the ordered pair 0 comma 1. Next I plug in a 1. 2 times 1 is 2. 2 plus 1 is 3. So when I plug in a 1, I get out a 3. And last one it asks for is 2. So when x equals 2, I plug a 2 into my equation. 2 times 2 is 4. 4 plus 1 is 5. So when I plug in a 2, I get out a 5. So for my 4 input values, I've generated 4 ordered pairs. I'll plot them on my graph provided. X coordinate first, then y coordinate. My first ordered pair is at negative 1, negative 1. So I go to negative 1 on the x and negative 1 on the y, and that'll be my first ordered pairs. I fill in my other ordered pairs like so, and there they are. We're doing linear equations today. Solutions of linear equations form a straight line. So today, whenever you're done, all your dots should be in a row, in a line. If they're not, you mess something up. These are not all the solutions to the equation y equals 2x plus 1. There's infinitely many solutions, but all my solutions will be along this line. So to show all of my solutions, I'll connect my dots, extend my graph beyond the edges of my coordinate plane, and then draw arrows to signify that they go on forever in both this direction and that direction. So this graph is all solutions to the linear equation y equals 2x plus 1. So you try the practice problem, y equals negative 2x plus 2. This time I did not provide you with the input values, the x values, so you get to pick your own. You can pick anything you like, but our graph only goes from negative 5 to positive 5. So I'd pick x values in there, otherwise you won't be able to graph them. And we're trying to graph them, so it would be pointless to pick other x's. So pick some. Be sure you pick at least 4. Plot them on your graph. Connect with a line. And we'll come back when you're done. So I don't know which x values you picked, but these are all the ordered pairs between negative 5 for x and positive 5 for x. Out of these, only these would actually be on my graph. My y values also go between negative 5 and 5, so if I got an output that was bigger than 5 or less than negative 5, it would be off my graph. So these are the only ones I can choose from. And you should have plotted them on your graph. So they would go there, connected with a line, and that would be our answer for our practice problem. So today's lesson is just graphing lines on a coordinate plane. There's really nothing more to it. You get input values, plug them in, get output values. These create ordered pairs. You plot your ordered pairs on your coordinate plane and then connect them with a line. So on the practice problems on the back, try them and then we'll go over the answers. Number 2 on the back, y equals 1/2 x plus 1. We have a fraction. Hopefully you know how to multiply fractions. Luckily this one is a half. It's really easy to multiply things by a half. You just find the half of whatever it is you're multiplying. So a half times 6 would be 3 because a half of 6 was 3. I get to pick which input values I want to do on this one. So if you picked even numbers, it'd be easier to do because it's easy to find half of an even number. If you picked odd numbers, it'd be fine, but you'd get out decimal answers. So for instance, we'll start with x equals 4. If I plug a 4 into my equation, 1/2 times 4 plus 1, half of 4 is 2. 2 plus 1 is 3. So when I plug in a 4, I get out a 3. If I plug in a 2, half of 2 is 1. 1 plus 1 is 2. So when I plug in a 2, I get out a 2. If you picked an odd number, that still works. Let's say I picked a 3 for x. So 1/2 times 3 plus 1. 1/2 times 3 is 3 over 2. 3 over 2 is 1.5. 3 divided by 2 is 1.5. And then 1.5 plus 1 is 2.5. So if I plugged in a 3, I should have got out a 2.5. So to plot it, we go to 3 on the x-axis and 2.5 on the y-axis. 2.5 would be halfway in between 2 and 3, so our dot would be there. So these are all our solutions to 2. On example 3, y equals negative x plus 3. There's a negative sign in front of a variable. If you want, you can turn it into a negative 1, so you could make the equation y equals negative 1x plus 3, and then it's negative 1 times whatever you choose for your x value. You don't have to, though. So for instance, I'll do one with you really quick. So let's say I picked a 2 for x. So if I pick a 2 for x, y equals negative 2 plus 3. So that's negative 2 plus 3, and negative 2 plus 3 is positive 1. So when I plug in a positive 2, I get out a positive 1. However, I plugged in a negative 2 for x, so my x equals negative 2. When I do that math, I get negative negative 2 plus 3. The opposite of negative 2, negative negative 2 is positive 2. So this turns into positive 2 plus 3, which is 5. So when I plug in a negative 2, I get out a positive 5. This also works if you think about it as a negative 1. I would have got a negative 1 times a negative 2 plus 3. Negative times a negative is a positive. So negative 1 times negative 2 is positive 2 plus 3. And again, 2 plus 3 is 5. Here's the math for 4. It's pretty straightforward, so take a look at it. All right, that finishes up our notes on graphing linear equations on the coordinate plane. You pick inputs for x, get out outputs for y. This creates ordered pairs. Be sure they're actually on your graph. They should form a line since we're doing linear equations today. So connect them with a ruler or a straight edge, arrows on the end, and you're done. Equations today, linear functions, and linear functions have oh man, how deep do I want to get? So if you don't want to have the hate of your great, no, this is getting weird. Okay, I'm gonna stop. Reset. The graph of an equation is the graph it has a, my next input value is at x equals 0. If I plug a 0 into my if I plug a 0, right, there we go. -5 and +5 on our x values. My next x value, number 2 on the back, y equals 1/2 x plus. So you can try the practice problems and then connect them with the line. Hope you enjoyed the video. Please click subscribe. Hope you enjoyed today's video. Hope you enjoyed today. Hope you enjoyed today. What can I say? Okay. Hope you enjoyed.